Here are the forms for perfect cubes. So you should have something cubed in the front minus or plus something cubed at the back. Notice we only have two terms. If we have those two terms being cubed, then we can factor it into the following forms. So for example, when you have x cubed minus 8, notice that 8 could be written as 2 cubed. So we have some term cubed in the front, some term cubed in the back. So we would rewrite this. This is our a term, this is our b term. Write this as x minus 2. We would square the first term. Multiply the two terms together, so 2x, and then square the last term. This is how it factors. Notice that I did not keep the sign with the second number. All I did was took the number and followed the form with the sign corresponding to it. So here's another form. We got 27x to the fourth minus 125x. Now notice that there is a greatest common factor of x, so we would take it out first. Then you should notice that 27 is 3 cubed and 125 is 5 cubed. So again, we would follow the form up top. Don't forget that you do have an x that you pulled out in the very beginning. So now following the top form again, we would have 3x minus 5. Square the first term, you get 9x squared. Multiply the two together, you get 15x. And then square the last term, you get plus 25. This is the factoring for that problem. Alright, here we have 3x cubed minus 6x squared minus 27x plus 54. Again, we need to do factoring by grouping, or at least try it. Group the first two together, group the last two together. Out of the first set, you take a 3x squared. You're left with x minus 2. Out of the second set, you take a negative 27. And you're left with x minus 2. Now the x minus 2's are the same, and the 3x squared minus 27 is the same. Now most students would stop here, but you should have recognized at the very beginning that we could have factored out a 3 from everything. Notice there's a 3 right here, 3x squared minus 27. I can still factor this 3 out, so I'm going to put it right out here in front. When I factor out the 3, I'm left with x squared minus 9. Now you should notice x squared minus 9 is a perfect square. It's a difference of squares. So you got x minus 3, you got x plus 3. We still have the x minus 2 and the 3 that we pulled out in front. And so here's another example. Again, we want to look for greatest common factor first. We didn't do it in this one, but we ended up having to pull it out later. So look for a greatest common factor. What will go into both 54 and 250? So I would pull out a 2, leaving you with, I would also pull out an x, because they both have x. So that leaves you with 27x cubed minus 125. Now notice this is in cubed form. 27 is 3 cubed. 125 is 5 cubed. So I could follow my form. I would have 3x minus 5. Then I would have 9x squared plus 15x plus 25. square the first one, multiply them together, square the last one. This is my factoring. Look for greatest common factor. They're all divisible by 3 and they all have an x squared. So that means this is x to the 4th minus 7x squared plus 12. Now from here you should be able to see 3 times 4 is 7, so 3 plus 4 is 7, 3 times 4 is 12. So hopefully you can just skip a lot of the work and say this is x squared minus 3 and x squared minus 4. Also notice that we have difference of squares again, so that one would be x minus 2 and x plus 2. Don't forget the factors that we had already found. Here is your answer. And one final example. Notice that we do have an x with all of them, and there's a negative in front that really screws things up with a lot of students, so I'm going to factor that out with the x. So if I factor out a negative x, that leaves me with 3x to the 4th plus 7x squared minus 6. Now I'm going to do this diagram method. 3, I only have a 3 and a 1. Has to be x squareds. Now when I multiply these together, factors of 6, I need to get an answer of positive 7 in the middle. So if I multiplied the 3 to the 3 and the 1 to the 2 and made that part negative, that would give me 9 minus 2, which is 7. So there is my factoring. That's all your notes for today. Please work on the assignment.